Hello, welcome to the episode of Rustacean Station. I'm your host, Alan Wyma. Today I have Ritchie Vink, the creator of Polars, on. Hello, Ritchie. Welcome to the show.
Hey, Alan. Great being here.
You sound not so energetic today. You're still getting your coffee in, right?
Yeah. It's in the morning. Though I am a morning person. Was a bit late yesterday, but I'll try to get my energy up.
Oh, good. Maybe you can just quickly introduce yourself so people know who you are, a little bit about your background, what you're working on, what is Polars, etc.
Yeah, so my name is Ritchie Vink. I have a background originally, depends on how far back you go, but I think things that matter in this space. I have a background mostly in software engineering and data science. Started as a data science software engineer and always was tinkering with hobby projects, learning new stuff, blogging about stuff. At one point I got into Rust, was building some Python packages to speed up some things for some smaller machine learning things. But I dabbed more and more into Rust, was using it also at the company I worked on a web server, and one day I wanted to load some files from disk and do a join on those files in Rust, and this was much harder than I anticipated. And I thought, maybe I can write something myself, and that's how I started with the idea of looking into query engines, DataFrame libraries, and that's when I started, at that time, a hobby project, Polars, which was meant to be a sort of better bear, as opposed to Pandas being the most popular DataFrame library out there. And that's how I started the new DataFrame library, Polars.
I always hear that term DataFrame. What does that actually mean?
It's most akin to tables in a database. The columns are homogeneous. That means you have a single type in a column. So and they have a name. For instance, I've got column shoe brands, and the type could be string, and then you have Nike, Adidas, etc. Or you have a column age, and then the data type would be an integer, and you have different ages. But you've got those constraints of a column type, a name of the column, and the other constraint is that the columns have the same length. So it's relational data, and then you build queries. It's mostly used for OLAP. So in query processing, you have typically, or in databases, you have typically two ways of doing things. Transactional is more inserting rows, getting a row out, but it's mostly on a smaller part of the data. It's very important that the transaction is correct and that you can reverse the transaction if an upsert goes wrong, etc. And the other flavor is analytical, and this mostly takes the whole data set and you do more complicated aggregations, joins. It typically involves a lot more data, and you can think of stuff like Power BI or Excel or dashboarding or batch workloads before you're going into machine learning models. But this ranges from small data, for a couple of hundred rows, to billions of rows. And what we wanted to do was being able to scale to pretty large data sets and handle them efficiently.
Okay. And the data frame, I mostly hear that term when it comes to data science, but you're saying it's actually not only within data science, but database frameworks in OLAP, right?
Well, in a database, it's called a table. You can think of it like, okay, we have a database table. And instead of keeping that abstraction at the database server, we're going to take it as a data structure in memory, or it doesn't even have to be in memory, but yeah, it has. We're going to represent it as a data structure in memory, and that way we can pass it through functions and have it as an abstraction in our own tools or in our own programming language. And this is much more native. I think it fits people's minds better than having the distinction data server, client. You're not going to keep your table representation in your structs or in your objects. And with data frames, you can combine them with your other data types. They can mean something. And a very natural thing, what it could mean is a data set for machine learning, of course. I think it also fits good with Rust. I think in Rust, people get nudged into data-oriented design, right? Where instead you have an object with some properties and you make a list of objects, you now create a struct, and you have in the struct field A will be a list of those elements. So they will be all aligned in memory back to back, which will have way better cache performance. This is what a data frame does for you. It's exactly what a data frame is in memory. And then we make sure that the operations you can do on those elements is SQL-like, relational or declarative.
Okay. What I've also seen is that Polars is based on Apache Arrow, which is a language-independent memory format.
Yeah.
That's also used in other data science tools, right? Which is different than Pandas, right? Pandas does not use the same thing, no?
It's a bit complicated because Arrow gets a bit conflated between implementations and the specification. And the first and foremost thing of what Arrow is a specification of how memory should be represented for it to be called Arrow. And it's similar to how you have different file formats, JSON, for instance, or CSV or Parquet. Only Arrow is meant for an in-memory representation. And if you're talking about numbers, this representation is pretty trivial. You can just have them back to back. But once you talk about nested data, strings, there are different ways to represent those. In memory, there were always different ways, but you can do this according to a representation. And this representation could be Arrow. And if more tools or more processes know about this arrow representation, you can just swap pointers. You can share a pointer to this other process, and if it knows the data type, it knows how to deal with that data. And this can save a lot of serialization and deserialization costs. So that's the cool thing about Arrow. Pandas is also adding a Arrow backend. They use the PyArrow implementation for that. But at the end of the day, it's just a way to represent memory. And then there are different implementations for Arrow. You have PyArrow, you have Arrow RS, you have Arrow 2. Sort of what's confusing is that all those implementations also add their own compute on top of Arrow. But in Polars, we have written all compute ourselves. So we only use the Arrow in-memory representation, but all the compute, the way we read this memory, the way we construct this memory, how we computed some aggregate, that's all written in Polar. So that you cannot say that if both tools are using Arrow, they would have the same performance, because it's still different. The implementation differs.
I mean, I would also think that, because my understanding is the power of Pandas and some of these other ones, I think Pandas is backed mostly by NumPy, if that's correct.
Yeah, that's correct.
And NumPy, I think, is still heavily dependent on C. And serializing back and forth between C and Python and all this stuff is quite costly, as opposed to you're staying all in one language, and one particularly quick runtime execution would definitely cause a big difference in terms of the performance, no?
So Python is really good in talking to C, and you don't really serialize when you use NumPy, or so the memory stays where it is, and NumPy knows how to deal with those pointers. So NumPy actually works super when you're dealing with numerical data. The thing is, NumPy is designed for numerical data only, and it has a concept of, for instance, missing data. So what Pandas did originally was represent those missing data as a floating point, not a number. But not a number from the floating point spec is something different than something being missing. This also gets problematic if you have integer data, because integers don't have a floating point none. So what they would do originally was cast those integers to a floating point, and suddenly when you get missing data, you will also get suddenly a different data type. So NumPy just wasn't designed for this, and it was still used to represent relational data, and that was a design flaw, which they're correcting now. So Pandas on the Arrow backend doesn't do this anymore. And on NumPy, I think they also did some tricks to represent missing data better. Another thing that doesn't fit into NumPy, for instance, is strings. So what Pandas by default does is just heap allocating a Python object, a string object, and putting that pointer into a NumPy slot. As you can imagine, this gets super slow if you traverse this, because you're pointer chasing, and you have every string access is a cache miss. Also, there's a lot of heap fragmentation. It's not a good representation for relational data, but they are correcting this. So in future Pandas, this will be better. But luckily, we've got more than only Arrow data as a design difference.
Well, obviously, you've been looking a lot at NumPy and how they do things. Has that caused you to make some design changes after looking at NumPy? I'm not saying after the fact, but Were things based off of NumPy originally, or you just kind of looked at what they did for ideas sometimes, or what's kind of the relation between Polar's development and the way NumPy works?
Well, no, we looked at Pandas and about not making the same mistakes they did. So I learned from Wes McKinney's blog 10 Things I Hate About Pandas. Was looking into database design, wanted to have a lazy API because I wanted to have query optimization, and just was looking into, okay, how should our the most important thing was that we did not follow the Pandas API, because that would make a lot of things very hard or impossible. So when I started, I was doing a lot of database courses and reading papers and thinking, okay, how do databases solve the query engine problems? And can we fit this onto a DataFrame data structure? So I think traditionally this has been a bit different. This has been, okay, we've got something to represent factorized computing like NumPy, and we're going to fit that into a data structure and we're going to make it work. And in Polars, I wanted to build the engine that's similar to how databases operate, and then make the data frame abstraction on top of that.
Okay. We also were talking before the show, since we're still on, since we just touched on some differences between Polars and Pandas, that you said if you compare the two, basically Polars is already able to do everything that Pandas does now. Is that's still the truth?
So not everything. It's always strange that because feature parity will be looked upon to the oldest, but Polars can do a lot Pandas can do, and Pandas can do a lot Polars can do, but Polars cannot do everything Pandas can do, and Pandas cannot do everything Polars can do. So we're sort of more feature complete on some levels, and they are more feature complete on other levels. But if we're talking about the core things you want to do with the DataFrame library, Polars can do everything you want. What's missing is maybe some exotic function. And if it's missing, we hope to give you the architecture to be able to build this yourself. So we've been very busy with setting up the architecture of our engine. The core concept is expressions, and at the moment we are also releasing a new concept called plugins, in which you can build your own Rust expressions and link them into our engine. So I'd say Polars it's feature mature. I think that's the better name for it. And comparing the feature maturity of one tool versus the other is it's hard to put percentages on it, because we do also things that Pandas cannot do, and vice versa.
Yeah, I was doing a little bit of checking while you were talking before, and I saw somebody was saying that Pandas is able to do multi-computer computation as opposed to Polars is not. Did I read that correct?
That's not correct. Pandas is single-threaded, single machine. There are implementations of the Pandas API that are able to scale it up, like Dask or Modin, but they also don't do the complete Pandas API. So they are able to take a subset of the Pandas API and scale it up. But if we're talking about Pandas is single machine, single-threaded mostly.
Yeah, and I also saw that Pandas is also significantly uses a lot more memory than Polars, right? Polars is definitely much more efficient with memory usage. It's another big difference.
Yeah, I think that because of two things. So Polars has got an eager and a lazy API. And the eager API is just, if you write an operation, it will execute it immediately and you will get a result immediately. But let's say you do a join and then you only need the first 100 rows. If you write the join and we materialize those maybe millions of rows that come out of this join and then do the head to get only the first 100 rows, that would be wasteful of the join materialization. So if you would have written this query lazily and you write the join and then say, okay, limit by 100 rows and give me the result, we know up front you only want 100 rows. So we only materialize the amount of rows we need. So this can be a huge speed up. And this saves also a lot of memory. So one reason why we are way more memory efficient is that Polars has a lazy API and a query optimizer, which means if you write your query, we only load the columns we need, we only load the rows we need. We do filters as soon as possible. So typically we try to apply the filters when we read the files. And for instance, if we're reading a Parquet file, we can sometimes even prove based on the statistics in the Parquet file that some parts of the file or the whole file doesn't have to be read at all. And with S3 data, we can sometimes even prove that we don't even need to download this data. So this can save a lot of time and also a lot of memory and bytes over the network. So one reason we can be way more memory efficient is this. The other is the arrow memory format, but Pandas is also going into that direction. The third reason is that we also, at the moment we call it hybrid, because at this point we're not as far as we want to be yet, but we can do the major operations like sorts, joins, group bys, and element-wise operations. We can do those in a streaming fashion. And streaming means that if you write your query, and as query you just have to think something you could write in SQL as well. If you write your query, then we can load the data in batches. We don't need to materialize everything in memory to be able to finish a result. So, for instance, if we do a group by an aggregation, we can just load these batches from disk, feed them into the hash table or the operation that does the group by an aggregation. And as you do a group by an aggregation, depending on the cardinality, so the cardinality is how many unique groups you have, the amount of memory shrinks down. Let's say you have only 100 unique groups, then we only need 100 slots in this intermediate states to do the group by aggregation. So the streaming engine can load data from disk and make the amount of memory needed way smaller. And if it doesn't fit into memory, some streaming operations are also able to spill to disk. So for instance, our sort, our unique, and our group by are able to spill to disk. If you don't have enough memory to finish the operation, we spill to disk and we handle it gracefully. So this is different from Pandas because Pandas just takes all data in memory, does everything eagerly, and it needs the amount of memory it needs to finish an operation. And the amount of memory it needs also typically has been, I believe, 10 times the RAM size or 10 times the dataset size. And for Polars, this has been lower. I don't know why this is. I think it has something to do with Pandas copying and the block manager, but I'm not sure, and don't pin me on this. I know how Polars works mostly.
As we talked a little bit before the show, I'd like to kind of get a high up understanding about, like, I'm a typical, what I would call a typical app developer in terms of I'm making software for end users. A lot of times it's just accepting data, validating it, saving it, doing some manipulation, some updates, some deleting, etc. Very typical app kind of stuff I'm mostly doing. Most apps are like that. That's boring, but that's bread and butter, and a lot of people still need those kind of things. Obviously, things get a little bit more interesting when I start being asked to create some reports so they can get, ideas about how the system's doing, how they're doing, etc. Why should I care about Polars? Should I even care about it? Would I ever run into this as a typical app developer where I would say, want to know about this so I can reach for it? I mean, I'm guessing possibly I might want to use it for building up reports, but what should I know about it as somebody who's in this kind of career?
So for as you said, the bread and butter for the transactions, Polars is not for that, and I wouldn't bother with it. For the report phase, definitely. If you have an app and you've got some local files and you want to ask some queries about those files, then Polars would be perfect for this use case. You don't have to set up a database. You can do this stuff in process, embedded in your application. It's way more lightweight than setting up a database somewhere. Or it's also way faster than doing it locally with SQLite. It embeds in Rust, so you can have some local files and ask some questions about those files. What we hear from more traditional application where we see Polars used in web services, that is being used to simplify the tech stack, to get a database out or do more stuff client side. So I think in those cases, it could help you in a more traditional app development. You mean app as in a web application, right?
I mean, it could be web, could be local desktop app. I guess we could say mostly web because it seems like most apps these days, when I say app, I mean application as opposed to traditional on your iPhone kind of thing. Yeah, I would say web app would probably be most likely.
So where SQLite would be the embedded way to do transactional, Polars could be the embedded way to do OLAP, so analytical. That would be a good way to compare those, I think.
That's interesting. I really want to get a more concrete example if you can think of something. And what you just said about like if we had a bunch of files and it'd be faster for us to just run that through polars rather than to set up a database, etc. Can you elaborate just a little bit more and maybe give something a little bit more concrete, like a bunch of CSV files, or what are you thinking about when you said that example?
Yeah, yeah, definitely. CSV, Parquet, JSON. You could, for instance, have a lot of log files, log rep logs, and you want to know when a kind of server failed, or want to parse the JSON into numerical things and want to do some computation. And anything, it's super generic. So anything you can think of, you can query. But instead of a database where you set up tables, a data frame is more, okay, we already got these files. We got these files in S3. We got these files locally on disk. Those files can represent data that's sent to us, data we stored, log files, and I have some kind of business questions about those files. And then I don't want to set up a table. I don't want to update a table. I just want to get the answer as fast as possible and then return a result on the fly. And then it's done. So where data frames are used, and where you also can use them a lot, is in data cleaning. You have some blob files from let's say these JSON with log data, and you want to get the information you're interested out of it, and then you want to save it into another file format, which is not represented as a string, maybe Parquet. So the next time you read it, it will be way faster. It will keep less memory. So that's more an ETL workload. You take some data from that is generated by a machine and you clean it up, for instance, and make it in something more manageable, or put it in front of your web app with a dashboarding. What we also see, for instance, is you have a dashboard where a client will use some sliders that represent the query, and you don't know what the query will be, but you connect it to, okay, this sorts the data, this gives a slice from there to there, and a user can modify the parameters of this query with this web application or with this dashboard, and then you give the result whenever the user says go. Especially when you allow joins and you allow different data sources, then you want something that's really fast, because setting up indexes, primary key indexes, will not really work in the database, because after the first join, those indexes are not useful anymore. So if things change a lot and you cannot know what kind of questions will be asked, this is typically in dashboarding, OLAP makes a lot of sense. And as queries get more and more complicated, indexes help less, preset indexes.
Okay, interesting. I'm already thinking about some ideas maybe I would be looking at using polars for. But these days, I mean, now that I've mostly moved to Kubernetes, I don't have a lot of hard files to kind of go through. I mean, I guess you can kind of translate some of the stuff to like log and gestures, like Datadog, etc. You can probably do something similar with that.
Yeah, it doesn't have to be a solution for a problem. So if you're doing web application and you don't have many files, or then you also don't need polars, because but what we see, if you're a researcher and you're getting a lot of data from measurements and you need to process this data, then polars becomes interesting. If you're a data scientist and you get a lot of data, it's more for those use cases.
Yeah, because for one project, we'll be getting a lot of data from very large landlords that want to import contract information, tenant information, previous contracts. I mean, it's going to get quite hectic. So that may be something we would do, but those are all ingested upwards over upload. So I'm not too sure if that would make more sense or not.
I think that sounds like a good fit. What do you mean, ingested upwards?
So we have a couple different sections. So I think the first step, I believe, would be uploading your current tenant list. And then it would be uploading maybe properties that you own too. And then contracts that would link between the tenant and, of course, the property itself. They have a historical background about how many contracts you've had with which tenants and for how long, and have they renewed, all these kinds of things. So there's a lot of overlapping things like that you'd have to run to make sure that we actually have, like you're not uploading a contract with a tenant that you don't already have, because obviously we'd be missing data. So you wouldn't have that in a database in order to link those. I'm not sure if this would fit the use case, but possibly, because I can imagine there would be years of data for some of these large landlords that we'd have to somehow link together.
Yeah, could be. I'd have to understand a little bit more, but it's super generic.
Yeah, exactly. I'm very, I'm not giving away
Yeah,
too much information because this is not what this podcast is about, but I'm just thinking maybe that could work. But for me, I'm just trying to think about where it would fit in my work so I can mostly understand. But I think I have some rough ideas. And like you said, maybe, I'm just trying to take a solution fitting it to a problem rather than I should be looking for a solution to a problem, right?
yeah.
What I also find kind of interesting, just taking a look at the Polar's GitHub homepage, is that you show a lot of documentation in straight Python. I don't even see like, at least not every block has a Rust how to do section. Are you going after the Python side? Because it's kind of where most of the data science kind of data frame work is actually being used, as opposed to kind of hitting both sides equally?
Yes. Well, it's mostly because our time is so spread out. We're currently with 4, but so most documentation actually has been done by contributors who just put their time in to do the documentation. And we got those contributors mostly from the Python side. Also, most of our users are on the Python side. So Rust helps us a lot because Rust is great for writing tooling. Polars is mostly used in ETL and in data science and also in interactive workloads. But doing interactive workloads in data engineering in Rust is perfect for writing the tools and making sure it's correct. So if I want to embed Polars as query engine in my tool, I think it's perfect. But if I want to do some interactive data science, it's not so ergonomic anymore because compile times are not so great. And if I do a debug compilation, but I have to crunch through billions of rows, this will be way slower than using this binary we pre-compiled for you in Python with all the optimizations turned on, all the fat linking. So you have a super fast binary and you can write your query and you immediately have a result. It can crunch through those billions of rows super fast. And I don't have the extra latency of the compile times. So interactive workloads make much more sense in Python. The machine learning tools are more mature in Python, so it's easier to use it and then write your query and give the result to the machine learning model you want to use. And in Rust, you can also do this. We see a lot of Rust users, but they are more in the ETL. It's just the ratio is way more shifted into Python. So yeah, there's also been more documentation in that direction and also more documentation help from Python users than from Rust users. We get this critiqued sometimes that our documentation isn't up to par or not good enough. My time is limited and I've got a lot of things I want to work on, and I hope people will help.
Yeah, I often hear about this. Just yesterday, actually, one of my developers, he was kind of complaining to me because for this one language that we're using, sometimes you can pass in a struct and sometimes you can pass in an anonymous function. And he was asking me, how come there's no documentation about, what this thing is and how do I use it, etc. And I told him what it was, but he was like, yeah, but there's no example here. I wish there was an example. Why is there no example? And I just replied back to him, like, instead of just complaining about why something isn't there that you already know about, why don't you just submit a PR so that way people who are similar to your thought would just, have that there so they don't have the same issues you're having now. You know what it is, you know what it can do. So just, why don't you just do it? For me, I don't really need that because I know what it is. But now that I see you complain, why don't you just, instead of putting the complaint, just put it to action and make it better?
Yeah. Yeah. Sometimes we get those issues like this is missing. And I was like, yeah, could you please help? Especially I've been working on Polars in my free time for, I think with some sponsored time, but also a lot of free time for 2.5 years. It's just a lot of work. And I always prefer to fix the bugs and prefix the things I know don't work. What I also find a bit hard about the Rust documentation is that it slows down our CI. We still need to find a good solution for this. But if you would have an example at every method or every function, the CI goes really slow because I believe Rust compiles a main file for every Rust doc separately. There should be some way around it. I hope this gets better one day.
I did see that they're making some changes to the front end. I'm not sure if that would fix the problem or not, or cause any changes where they want to do that all in parallel now. Have you seen that? They're going to do things in parallel on the front end now rather than just only the back end?
Yeah, I saw it. Hoping more from Crane Lift. So the Rust compile times are good until they aren't. The thing with the DataFrame library is data frames are so generic that we need to have functions and algorithms for all kinds of stuff and all kinds of data types. So I think we're one of those projects where compile times are the worst, because the amount of methods, the amount of functions people request, the amount of code you need to generate, it's just insane. So we suffer from compile times. We have a lot of feature flags for our end users so they don't have to compile what they don't need. So, but in our CI, we have to test everything. We've been looking at next test. This helps a lot. It's a lot faster, so I don't know what they do differently. So for the testing, that's okay. Only the Rust docs are still slow. I believe they make a separate binary for every document, every doc test.
Okay, that's interesting. I didn't know about that. I do know that people always just complain how slow it is, but I don't know.
Yeah.
I think it depends on how much code you have and all this other dependencies. Probably the worst part is like, I feel like we're kind of going back to JavaScript days where we just pull in a dependency for every little thing, but maybe I'm being dramatic.
Well, yeah, the dependencies doesn't hurt us as much. It's mostly, as I said, a DataFrame library has a method for all kinds of computations. So the easy thing is a median, but then people want an approximate median or a hyperlog log and you can continue. If there is a new algorithm, maybe you can also do it on a data frame. So the amount of algorithms just are insane, and they keep increasing. And it's hard to say, okay, there is a limit where we say, okay, this fits and this doesn't. But if you take everything that fits, you will still have I don't know where we end up, what all you can do. But yeah.
It seems like Polars is pretty kind of stable and has found its place, right? But like you said, there's always a million things to do. Have we actually reached a Polars 1.0 yet? Or because, it's still at 0.19, right? So what's stopping to get 1.0?
So we are planning on going 1.0 after the next breaking release. So there are a lot of operations we're very certain about. We are considering ourselves 1.0 as being production ready and thinking about backwards maintainability. In the meantime, we're also adding new operations where we're not certain about. But we will always keep doing this because we have a lot of new stuff we want to add. So Rust has this unstable way to introduce stuff, which we would like something similar where you can say, okay, we add this method. We're not entirely sure about this. Let's bring it out in the world so people can give feedback, and then we can stabilize it once we know more. In Rust, this is easier doable. In Python, less, because if something is public, it's public. So you need to document it, and then people will still use it, whatever, because that's how it works. But I think we're going to go for some similar strategy, because I don't like semantic versioning about that one number saying something about the whole API. But yeah, we have to go there. So we plan going there, but we're also not certain about everything.
You're still making final touches on the final APIs, and you already have a plan when the 1.0 release will happen, right? Basically after the next break-in release. So are we expecting that like 6 months or 1 year, or kind of where are we? Because people are still going to be nervous about putting things into production without that 1.0 official tag on it, right?
So we would be 1.0 sooner than that, I think a few months. The thing is, we are going 1.0 for our in-memory engine. For our streaming engine, it's still in beta, but you cannot have a tag 1.0 for this and 0. So we have to go somewhere. So it will be 1.0, but there will also be a 2.0 later, because there is also stuff we're adding which doesn't change the API. But I think it is easier when you have a tool that does a single thing and your API is rather small. You can say, okay, at this point we're ready. But on a DataFrame library, the amount of surface area is so big, it's just impossible to say we're ready and we're not going to change anything.
Yeah, I can understand. I mean, trying to figure out if things are going to be perfect for a while is definitely not going to be easy to do.
Yeah.
That's why you have 2.0, and you've seen with Rust, right? Rust is still 1. Whatever, but we keep having this I forget what that's called, the change in the syntax, but still not change in the actual stuff. Like when we went to like 2018 and 2021, I think.
Additions.
Yeah, the addition. Yeah, that's right. It's kind of like maybe this is too crude to say, but kind of like a little bit of a hack where it's like, all right, we're not 2.0, we're not 3.0, we just changed the addition. Everything is still the same. It's like, okay, fine. Technically, yes. You have that just kind of like addition changing,
Yeah.
which is interesting. Nobody can predict the future, right? Like you said, you didn't expect to be working on polars. It's kind of a byproduct that got sidetracked. And I think you're pretty happy where you are, right? What keeps you working on polars? What is it that keeps you attracted to it? Because there is people who do walk away for different reasons. One is, maybe they lose interest. I think the guy who started Rust is not really obviously working on it so much. I don't know if he still uses it or not, but you also have what's his name? The guy who created Python. I forgot his name now. Your compatriot. He stepped away from
Guido.
Yeah, he stepped away from doing the BDFL, right? I think he's still a Python developer. I think he called himself a normal Python developer now. He's out of it, right?
He's still very much involved, but the open source or being the one making the decisions, it's got two things. It's great. I mean, I've been able to build something and you get a lot of gratitude from people who say, oh, this made my life so much easier. This made stuff so much faster. Or I love the API, or that's super to experience. On the other side, open source can also be draining because sometimes you make a decision because you think it's the good thing for the project, and people can be pretty harsh. And I think that can be draining for people. And of course, the amount of information you need to process. If you only want to follow the issue tracker, you cannot keep up at a certain point. If I look to myself, I'm just someone who loves to code, and that keeps me into the project. First and foremostly, we also got funding, so there's a second reason that keeps me into the project, but that's only since this year. I just love working on polars, and I love having my ideas. I've got a ton of ideas and bringing them to fruition, and that's the most important stuff. Though sometimes you wish you could have a bit more clean slate, and you miss the days of programming where you could just do what you wanted instead of having all the bugs, all the all the issues. Changes are not that easy anymore. It's not only a playground anymore. Most open source developers experience some sort of flavor of these things, and maybe some different things as well.
I think I have a pretty good idea kind of where polars is and if I should or should not be using it for any kind of problem I run into. Is there anything I didn't touch on today that you think people should know about? For instance, we covered about you're looking at releasing 1.0 and what that actually means. Is there some features that you think we should be on the lookout for that you think are really exciting that people should know about?
What I'm really happy about lately, I've been talking a bit about the amount of features we have, the amount of code we have, and I've been thinking, okay, how can we grow with polars as a library without bloating? And for me, a distinction, for instance, we also have nested types and we have an array type, which we will make better. In this type, you will have ND arrays. So you have a column with ND arrays, which can represent the tensor for a machine learning model. Though I don't think machine learning algorithms should be in polars. I think that's a distinction, a boundary where we say, okay, this is too specific. Distance functions, machine learning algorithms, etc., all kinds of feature engineering. But I do think it's very natural to work with them in a DataFrame library with our expressions, with our API. So what I wanted was being able to make a polars machine learning library or any other something that doesn't fit into the polars main engine or main library, but something that would fit if we would not care about bloating. So we started something new, which is called the plugin system. And with this, you can create your own functions, sort of UDFs in Rust, and you can tag them with a proc macro, and then they will be exported as an expression. And when you're in Python, you can compile your own library. You can publish it on PyPy, the Python package manager, the package repository. Your own binary can be linked into the polars engine, into the polars main library. And this way, you can build your own custom tooling, your own specific logic which should feel native. It feels really native within Polar. So I hope this way we can have an answer to the feature problem where we want a lot of features into this engine, but we don't want to compile everything in this static library we have in Rust.
That's good to hear. This is a side question I think I mentioned to you before, that I talked to somebody here who is in data science and they were talking about polars. He actually has a specific question for you I thought I would ask. He says, is there any plans to make polars work with Postgres PG store, the standard vector store in Postgres using PGRX, the embeds Rust in Postgres? I'm not sure if that makes sense to you or not.
It's an overly specific question.
Well, he's working on an idea that involves this stuff. So that's why, I guess.
All right. I am not familiar with the embedded Postgres store, so I cannot really answer this right now. I should first know what it is before I can say if Polars will integrate with it. Saying no would always age very badly. Sometimes I said we will not do this, and then later it seems to fit. So I don't know.
Yeah, I think that's kind of what hostage negotiators do, right? You're never supposed to say no. It's bad for the hostage. So probably good to say, we'll look into that rather than give a negative answer, right? It's kind of maybe a horrid reply, but yeah, I understand what you mean. Things change, right?
Yeah, though I would say in open source, it's important to say no, to keep true to the core of what you want to do. Otherwise, you will end up with API bloat. You will end up with stuff that just doesn't fit. I think it's one of the most important things to say no. But sometimes my no didn't age well.
I think I know what you mean. I've been following some programming languages, and the creator will kind of say no because he has to. Like you said, it's easy to put things in, but to take it out is really difficult if you need to.
Yeah.
And I think it's what you're talking about mostly, right? Or supporting something long term.
Yeah, if it doesn't fit the architecture you're building, if it doesn't fit the way you want things to work, and it will hurt people's intuition, or you have a sort of a model of your API, and for Polars we have a DSL, which is sort of a super small programming language, and it should follow adhering those rules. And I don't think we should make exceptions on those rules, because that would be strange. That would be, how will people learn this, or how? And sometimes it doesn't fit the architecture, or you're not there yet, or sometimes it doesn't fit the paradigm you're building. I think in Rust it's also very common. The Rust language also, I think Rust does very well keeping things unstable when they're not certain about it. As we see, it can take 5 years for something to stabilize because we're just not certain, and you can work around it in the meantime.
Yeah, that's true. I've been using Nightly to build something that I use in production or something else. So it is interesting that, like, even if you need to, you can always use Nightly or the beta, right?
Yeah.
But yeah, it was good to have you on. Good to know more about polars and to understand more about what a data frame is and if I should be looking at using polars for anything. Thanks again for coming on, and hopefully I'll have you again in the future.
Yeah, thanks for having me. And till next time.